In this demonstration, we will enhance our ability to explore the properties of instantiated .NET variables. Instead of limiting ourselves to properties of one hand-picked object, we will see how to explore properties of all instantiated .NET variables. I will show a runtime demonstration, describe the program's main concept, and finally discuss some selected lines of code. The Property Inspector project code is yours to explore and use. Before watching Property Inspector in action, I'll start with a short demo of the program we want Property Inspector to explore. We are looking at a program that handles document scanning and involves all kinds of .NET variables from different vendors, some of which are form controls and some are not. Instead of explaining what classes are used here, let's just run the program, see how it works, and then invoke Property Inspector to explore what's under the hood. Now let's call the Property Inspector. As you can see, I've included implementations both with Telerik controls and Microsoft ones. Let's start with the implementation by Microsoft controls. On the left side, we see a data grid view control populated with basic information about all the currently instantiated .NET variables. Each variable is represented by a row on the left, and for each selected variable, its property grid control is shown on the right. The information I chose to show on the grid includes the name of the variable within MAGIC, the vendor name, and the class's fully qualified name. Now let's run the task that uses Telerik controls and see a nice grouping feature of the rad grid view, which I'll use here to group classes by vendor. This functionality is out of the box, and no special coding was needed, except for tweaking one property in order to have the rows expanded rather than collapsed, which is the default. Now let's use the Property Inspector to play with some properties of various objects. Let's start with changing the image of one of the buttons. And let's play with the radius of the dots on the weighting bar. Let's change it from 10 to 25 and see how it affects when running the program. And now let's have a quick look under the hood at the concept of the program. This tiny program is just for testing purposes, instead of the scanning program I've used earlier. It contains various Microsoft controls. Let's call Property Inspector to find out which. Before we go into the main program, let's have a look at the necessary assemblies needed for this project. These are the assemblies. And let's also have a peek at the .NET aliases that I've defined for this project. Pay attention to the fact that I use uppercase letters for the alias itself to differentiate it from a real namespace inside the program. First of all, these two tasks can be deleted if you decide to choose the implementation with the Microsoft controls. The necessary adjustments should be done in the Property Inspector tasks. Remove them from here. And now let's go to the main two tasks that interest us. The get.NET variables, which actually populates the grid, and the interface that allows us to go over the variables and change the properties of each one. Now let's focus on the get.NET variables task. The purpose of this task is to collect information about all the .NET variables available up the task tree from the very first variable in the main program down to the first variable in our program. This is done by using var functions, but omitting the var literal, and thus the task sequentially scans all of the variables using a simple counter. Then several filters are responsible to remove all non-relevant variables. First of all, only a variable with the E literal is relevant, and only if it's an instantiated one. Then, A partial safety net tries to eliminate .NET parameters that are defined within .NET event handlers, as trying to access them outside the scope of the handler will most likely lead to a crash. Once I've filtered the relevant variables, I assign them to a system object, check that the object was indeed instantiated, and finally check if it exposes any public properties. All that is now left to do is populate the data table with the relevant information about the class with the help of these operations. As for the interactive task, there are a few worthy issues to point out. First one is the use of a splitter control. I would like to mention not the functionality, but the fact that in this case the grid view and property grid controls are not placed on the MAGIC form at all. Thus they are not automatically instantiated by MAGIC like the splitter control. This means they should be explicitly instantiated before being attached to the splitter. Last thing worth noting is the selection changed event of the grid view, from which the selected object property of the property grid is set. Pay also attention to the dock property of the splitter control and the controls assigned to the panels within it.
That's all, folks. Interesting.